Welcome back to Thinker's Corner. Now, remember I said in my last video that I wanted to demonstrate with a real-life example. So here's a real-life table that I have on my board. This is the error function table, normally used for, I believe, material science, for finding concentration and diffusion. I believe it's Fick's law. Fick's law is what it's called. So here we're going to, let's use these two values and let's try and find a value in between them. So I'm going to say z an error function z. Sorry about the lean line. So z and error function z. We have 0.55 and that corresponds to 0.5633. Let's make it a little bit interesting and let's make it work the other way around. Let's take a random value in between 0.5633 and 0.6039. Let's try 0.59. So 0.59. We don't know what our z is, so we just go call this z, and then 0.60 matched up with 0.6039. So we can put this away now. Let's interpolate this. Now remember that we said in the first video that the formula is upper boundary. So we're just going to write it as up b minus the lower boundary, low b, over mid value minus the lower boundary, equal to the same just on whichever side that you want to find the unknown. Alright, now let's try and find z. If we look, we see that our upper boundary is 0.60. It doesn't matter which side the z is on, once you keep the corresponding formula, it will work out to be right. So 0.60 minus our lower boundary, 0.55, mid value z minus lower boundary value 0.55. Then this is going to be equal to upper boundary 0.6039 minus lower boundary 0.5633 over middle value 0.59 minus lower boundary 0.5633. Let's work this out now. Just bracket this off. Alright, so let's work this out now. Suppose be 0.05 over z minus 0.55. Let's just calculate what we have on the right hand side quickly. So my calculator. Okay, 0.6039 minus 0.5633. That works out to be 0.0406. And then let's work out 0.59 minus 0.5633. You can see the value there. So that is 0.0267. Let's just work out this fraction quickly and turn it into a decimal. 0.55 over z minus 0.05. Let me just make that correction quick. (0.05) minus 0.55, and then we're going to work out what we have on the right side. So that is 0.0406 divided by 0.0267. Works out to be 1.5206. And then, as you know, go for cross multiply. So 0.05 equal to, and you get the gist. We just have to, we'll go expand it. Okay? So it's going to be 1.5206z minus this times this. So 0.55, 0.8363. Going to add both sides by the 0.8363, so we'll get 0.05 plus 0.8363, and then this will be equal to 1.5206z. Now we're going to add 0.05. We get 0.8863. This will equal to 1.5206z, and then we divide both sides by 1.5206z. Sorry, 1.5206, and then this will give us z equals to 1.5206, 0.582. So if we go back to our right side now, our z is equal to 0.582. And what you can do is, because these values were given in 2 decimal places, you can just round this off and keep it at 0.58. So therefore we found the value of the original z value using an error function value that we were given. So it works. So the linear interpolation works both ways. You can use it to find the function value, or you can use the function value to find the value before the function was carried out on it. So that's linear interpolation. That was the